All right, so the last one we're going to do is for the Unit 4 review, number 17 on page 404. Again, you want to do this before I do it so that you can kind of build confidence in your own abilities and not a false confidence in mine. So I love this question because it's dealing with multiple choice questions, which I know are your favorite types of test questions. And as we know with a multiple choice, you can either get a multiple choice right or you can get it wrong. And so it's something that I can only get right or wrong. That gives me two choices. Probability of getting it right always remains the same, especially if it's 4 answer choices. That would be 25% to get it right. And my 50 questions is less than 10% of all possible multiple choice questions that are out there. So it's independent. So I'm looking at this, and I have a multiple choice test, 50 questions, 4 answer choices each. Get at least 30 correct in order to pass the test, and the questions are very difficult. So for this one, I can say I've got a Bernoulli trial. So looking at what we're going to need to answer, it says, are you likely to be able to pass the test by guessing on every question? Suppose that after studying for a while you believe that you've raised your chances of getting each question right to 70%. So that's just not straight up guessing, that's educated guessing. How likely are you to pass now? And assuming that you're operating at the 70% level and the instructor arranges the questions randomly, what's the probability that the third question is the first one that you get right? So that's until I get one right. So let's take a look at this. So we have got multiple choice. We've already determined that it's a Bernoulli trial, and currently I can say it can be modeled with a binomial model. My sample size is 50 questions, and if I am straight up guessing, not educated guessing, I know that there's a 25% chance of getting a question right. So letter A is asking us, are we likely to be able to pass the test by guessing on every question? And remember, passing the test is getting at least 30 correct. So that means I need to get at least 30 correct. Could be more, but it has to be at least 30. So remember, our calculator doesn't play nice with at least 30. So I'm going to turn that into the complement. And then I'm going to say 1 minus probability of x being less than or equal to 29. And then I'm going to write this out. Now there are a lot of terms that are going to be here. So I'm going to put in a big old bracket. And I'm going to say 50 questions. How many ways can I choose? 0 of them. 0.25 to the 0. 0.75 to the 50. Remember, your exponent need to add up to what that top number is. Plus 50 over 1. That would be getting one of them correct and the rest incorrect. And I'm going to invoke my right to be able to ... because I've established my pattern. And I'm going to do the last one. So 50 over 29, which means that 29 correct and 21, that would be a little higher than 50. Oh no, that's 50. That's good. All right. Now, I can just go ahead and put this in my calculator. Remember when you have something that is cumulative like this, I can use CDF. So I'm just going to kind of do this in pink on the side because this is nothing that I would ever even dream about writing on my paper. But in my calculator, I would do 1 minus, and then this would be binom CDF. And remember, it's your parameters first. So you get 50, comma, 0.25, and then the value that I'm interested in being less than, and that's 29. Now that's something that I would stick on my calculator, but I would never put it on my paper. So I'm going to pretend that pinkness never happened. Because all I had to do is write out the equation, which I did above, and then I would write my answer, and I would say, well, that equals a very teeny, teeny, tiny number. 2, 3, 4, 5, 6. I mean, in fact, it's so small. It's almost a 0% chance. So I would say, according to our binomial model, it is not very likely that I'm going to pass this test if I guess on every question. So I better get my butt studying. All right, so now I study a little bit. And now I have increased my chances of getting a question correct to 70%. So now my model is changed to be 70%. Well, that's a lot better than 25%. So now I want at least 30 to be correct again. So I'm going to do probability x is greater than or equal to 30. Again, I'm going to go ahead and use the complement because I can't do that greater than in the calculator. And I really want to write this in a way that I can put it in the calculator. Kind of helps me think about it. So I know that we just wrote the equation up top, but let's just do it again because it's great practice. So now I got 50 over 0 again. But now 70% chance of getting it correctly, and here I got none correct. 30% chance of getting it incorrect, and I got all 50 incorrect. Or I could get 1 correct. And 70% chance of getting 1. 30% chance of the rest. Invoking my right to plus dot 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 plus. 29 correct. And then here I've got 21. Again, I would write out that work. I'd go ahead and I'd put it in my calculator, but now I'm just going to answer the question. So when I get it in there, I get 0.952. So this time, let's just write out our sentence. So the last time I said, according to our binomial model, it's very unlikely that I'm going to pass the test by guessing on every question. So here, let's write it out. So we've got according to the binomial model, you have a 95.2% chance of passing, and I would say with a little studying. Time to crack the books. All right. Now let's hit the last question. So letter C here. Letter C asks us, assuming that we're operating at the 70% level and the instructor arranges the questions randomly, what's the probability that the third question is the first one we get right? So now I'm going until I get something right, which means I want the first two to be wrong and the third one to be right. So now I'm going until I get a success. So this is a geometric model. And it's kind of helpful to think about that. You know, that your success is happening at a specific point. So I'm going to look at the probability of x equaling 3. Which means, in other words, I want the first two questions to be incorrect and the third one to be correct. I don't care what happens after that. That's not the question. The question is this. So I get 0.063. So according to our model, in this case our geometric model, we have a 6.3% chance of getting the first correct question on the third question that we answer. So again, this is number 17 on page 404 in your Unit 4 review.